Here is a simple diagram of the major elements that make up an O-RAN mobile network. 5G-Spector integrates into an O-RAN stack by instantiating a security-focused service model called the SecSM and an analysis algorithm hosted within the RAN Intelligent Controller, or RIC. The SecSM is used to create an entirely new E2 telemetry stream, which we've specifically designed to give our XApps visibility into all the security-relevant state transitions and RAN statistics that we need to detect attacks and other security-critical activity or anomalies. So, to illustrate, let's consider a mission-critical example of a 5G network. Using a relatively low-cost commodity SDR, an adversary who is simply in radio range of your base station can take down the network using various Layer 3 5G protocol attacks, such as the BTS resource depletion attack. To illustrate the threat, we'll use a few Android phones that are streaming video live through a 5G network, and we'll use an EDIS B200 USRP to target the base station. We'll also use our modified O-RAN stack with SecSM to produce a MobileFlow stream, which will enable 5G-Spector to detect the attack as soon as it executes. For the demonstration, we'll use our SE-RAN mobile network attack testbed, running Euro OAI, ONF's SD-RAN, and 5G-Spector. Okay, here's a live Zoom room with two Android phones with cameras that are pointing at monitors showing different YouTube fish videos. The upper left window runs our attack console, which controls an SDR that will be used to perform a live RF BTS resource depletion attack against our testbed's base station. The attack effectively expels all active client mobile network sessions from our network, killing our Zoom sessions. But here, 5G-Spector analyzes MobileFlow to track the attack's malicious session establishment flooding pattern, and then immediately generates an alert. And here's another 5G protocol exploit that could be quite useful if one wanted to surgically disconnect just one mission-critical 5G device without disabling the entire network or disturbing other devices. This time, we will use a TIMSI spoofing Layer 3 exploit against a single client device, which causes the base station to continually drop the victim device's connection. The setup of this demonstration is just like the previous attack demo, but again, our goal is to target a single victim device while not disturbing the entire RAN or other peer devices. Okay, so here are the same two phones streaming fish vids on Zoom. From the attacker console, let's launch the TIMSI spoofing attack using our SDR against the phone session that is displayed in the bottom Zoom window. The Layer 3 spoofed TIMSI arguments of the attacker are reported within the MobileFlow stream, and we can see the resulting threat alert, including the victim's TIMSI and the detected exploit method. But more broadly, in recent years, the mobile security community has continued to uncover a wide variety of exploits against the latest 4G and 5G mobile link and session establishment protocols. These vulnerabilities are deployed globally and affect nearly every cellular network. In fact, here's a table of the various attacks that we've been studying, along with the current status of threat coverage provided by 5G-Spector. The exploits the 5G-Spector addresses can enable adversaries to disrupt, spoof, or flood Layer 3 messages to compromise the security, availability, and privacy of 4G and 5G networks simply by being within signal range. By the way, there will also be a full paper presentation of the 5G-Spector project that will be presented at the next NDSS conference in early 2024. For more information about 5G-Spector, MobileFlow, and our other O-RAN security modules, you can visit our site at 5gsec.com.